Hello, ladies and gentlemen. We've got a pretty simple day here for you today. We're going to talk about 10.6, which is more angle arc theorems. Yes, there are more after the last two sections that you've done, but these are the last of our angle arc theorems. And these are just some miscellaneous theorems that don't pertain to any specific type of angle necessarily, but they do help you to be quicker about calculating angles and arcs because they can give us some shortcuts. So here are our theorems. There are three of them. The first one says if two inscribed or tangent chord angles intersect the same arc or congruent arcs, then they are congruent. And this is something we've already seen. So then they are congruent. All right, and all this means, this is again something we've seen before, it means that in this diagram, there's an arc right here, and this angle is an inscribed angle that intersects that arc, and this angle is an inscribed angle that intersects that arc. And all this really means is that both of those angles have the same measurement, and we already knew that, right? If two inscribed angles intersect the same arc, they must be the same measurement. So that's not really a new theorem at all. That's just putting some words to something we've already seen a bunch of times. The next one we've seen a couple of times, but maybe not dug into quite so much. But another inscribed angle theorem. An angle inscribed in a semicircle is a right angle. All right, it's a right angle. So if we have this semicircle, and that means that we have a 180-degree arc, an inscribed angle is going to be half the measurement of that arc, so an inscribed angle is going to be 90 degrees. But that means that whenever, oops, didn't spell angle right, that means that whenever we see a inscribed angle that has endpoints on the diameter, no matter where it is, we know it's a right angle, right? We could make another angle in here. So there's a right angle, could go like way over here, and then up to here, and that would be a right angle. So there's all kinds of ways that we could do this drawing, but we would always end up with a right angle because it's an inscribed angle whose endpoints are both of the endpoints of the diameter. And then the last one is the most complex in terms of how you find it. So it's a simple theorem, but it's really helpful to us, and it's one that I personally tend to forget as I'm working. So it's one that I have to remind myself, oh, this is a theorem we have, and this is a theorem that we can use if we don't feel like we have enough information. So this says the sum of the measures of a tangent angle and its minor arc, the small arc, is 180 degrees. So this arc and this angle together is 180 degrees. There's our angle. Maybe our angle is 20 degrees. That means that our arc would need to be 160 degrees. All right. So there's a couple of ways to think about this one. But if you think about taking this circle and using the two endpoints where this tangent angle meets as the endpoints to an inscribed angle, then it makes a little bit more sense. So if we have the endpoints here, maybe this is S and P, and we change this from a tangent angle to an inscribed angle that goes out on S and P, then this arc is going to be half of the angle that we get, or sorry, twice the angle that we get. You know what? There's really no reason to explain this one. It would just take a long time. But what we do want to know is that every time the angle and its minor arc are going to add together to be 180. All right, if you want to know why, here is the algebra behind it. But again, I won't make you know what this all means. So another thing we're going to do today is just use some of these theorems. And again, it's not too hard. So the first one says find x and y on all diagrams. Well, this is easy. We have two inscribed angles, and they're both inscribed on a 120-degree arc. We know that our inscribed angles have to be half the arc measure, so we know that they have to be 60 degrees apiece. And that's all there is to that one. Here we have a diameter, which means we know we have a 180-degree arc, and we have an angle that is inscribed onto the diameter, onto the semicircle, so we know that's a 90-degree angle from the theorem we just saw. All right, down here we're going to find some missing sides of a triangle. It says in circle O, BC is a diameter, and the radius of the circle is 20.5 millimeters. So we could write 20.5 right there. Chord AC has a length of 40 millimeters. Find AB. So the really important part in here is the part about BC being a diameter, because if that's a diameter and angle BAC opens onto a diameter, then from our theorem today, angle BAC is 90 degrees. So if that's a right angle, and we see 40 and we see 20.5 as the radius, we can double that. We can say that the whole diameter is 41. And then we can just use the Pythagorean theorem, right? We can say 40 squared plus x squared equals 41 squared. So that's going to be 1600 plus x squared equals 1681. Subtract 1600 from both sides. We get x squared equals 81. And then take the square root and we get x equals 9. So AB is going to be 9. Right, there's another new Pythagorean triple for us that we probably don't see very often. 9, 40, and 41 there. And then there's one more example problem for today on the back of the sheet. So we have to use chord angles to figure this one out. So I don't know if it's really chord angles. It's not. It's secant angles or secant tangent angles. So this is the wrong thing to write. We've got a secant angle and a tangent angle instead. So we are given PY and QW are tangents, right? They're tangents there. And arc WZ is 148 degrees, so 148 over here. Arc XY is 36 degrees, so we can say that this is 36. We want to find arc PQ, the one over here. So we're going to use a couple of things. First of all, we see a secant angle right here. And we know how to find the measurement of the secant angle, this measurement right here, because we can say that that is half of the difference, of half of 148 minus 36, right? And so that's going to be 56 degrees. So this angle is 56 degrees. Also, we have a vertical angle to that angle. So we know that that vertical angle must also be 56 degrees. And then we somehow have to find this angle right here, or this arc right here. Luckily, we have a theorem from today. And our theorem from today says that in a tangent angle, like this angle right here, the angle measure and the smaller arc, the arc closer to the tangent angle, have a sum of 180 degrees. So we can just say 180 minus 56, we get 124. And so this arc right here is a 124 degree arc. And that's all there is to it today. Nothing too fancy. So go ahead and work on the 10.6 worksheet.